Okay, today we're going to start out by looking at the homework that we did last night. And so if you could pull out both your worksheet and the bookwork, we're going to go over those things first. So I have the worksheet and the bookwork so we can look at those. Okay, on this worksheet, this was about the bakery and what they sold on the days June 1st through June 14th. And then it was how many of the chocolate eclairs that were sold on those dates. So the first question says, what are the independent and dependent variables in the graph? Well, the independent variable would be the days in June, and the dependent variable is the number of eclairs that were sold. For which dates does this graph provide data? It only goes from June 1st to June 14th. Does it make sense to connect the dots? Well, no, it doesn't. And if we think about it, if we connected them, then we're saying, hey, there's a June 1.5. Well, there's not. There's only a June 1st and June 2nd. There's nothing in between. So if we should not connect the dots because this is discrete data. There is nothing in between. Okay, then they ask you to use your function notation. Find S of 10 if possible and explain what that would mean. So what that means is on June 10th, that's our input, the date, they sold 13 eclairs. S of 10 equals 13. And so what that means is on June 10th, they sold 13 eclairs. Find S of 15. Well, here's the 15th, and we have no data on the 15th. So this is not possible. For the situation we were given, it is not possible to find S of 15. If possible, find T such that S of T equals 15. Okay, so what is this asking us? When did they sell 15 eclairs? So if we come up here and we look at 15, I missed it, but I'm going to move it down, see if I can get it close to 15. Okay, there we go. Now we're close. In between the 14 and the 16 is where the 15 would go. And do you see that only occurred in that one spot right there? So it only happened on June 8th. So the T would equal 8. If possible, find T such that S of T equals 11. So if we take our line and we pulled it down to 11, do you see there's nothing at 11? So that is not possible. There was not a day where we sold 11 eclairs. H, find all possible values of T such that S of T equals 12. Well, this happens more than once. It happens here and here. So on the 1st and the 11th. Then it asks us to find the domain and the range. Well, since these were discrete pieces of data and there's no day 1.5 or 2.25 or 3.00005, since none of those exist, we have to give the discrete days here, 1 through 14. And then the range is just those values of eclairs that we actually sold, that we have data for. So 9, 10, 12, 13, 15, and 14. 14 and 15. Okay, take a moment and finish checking that up. And if you need, ask your substitute today to please hit pause if you need more time. And you can do that anytime during the video. They could hit pause if you needed more time to look at something. Okay, I'm going to go on to the bookwork now. And your bookwork last night was on page 207. So I'm going to look at page 207. If you'd like to follow along, you can flip to page 207 also. And we can look at these problems. So let me get this out of the screen. All right, so on 207, we started with number 23, which said a mail order company charges $5 per order plus $2 per item. So $5 for the order and $2 for each item, up to 4 items. So our domain can contain 1, 2, 3, or 4 items. Now, we can't sell 1.5 shirts. So this is not a continuous domain. We have to give those discrete 1, 2, 3 elements. Well, 1, 2, 3, 4 elements there. Okay, so if this is our possible input, our domain, then what's our possible range? What would our output be? We'll plug it in. Plug in 1, get out 7. Plug in 2, 9. Plug in 3, get out 11. Plug in 4, get out 13. So those were our possible ranges. Number 30 was an error analysis problem. It says Rashid saves $150 each month. He wants to know how much he will have saved in 2 years. He writes the rule S, and let me put this on pen. Okay, so he writes the rule S equals M plus 150 to help him figure out how much he will save. Well, this M is what should be multiplied times the 150, not added to the 150. And that's what it says here. It should have been multiplied, not added. 32 was another filling up the pool. And you know what? I think we may have done that one in class. So you guys should have been great with this one. All right. 34 is G, 5.25p. 36, an acceptable domain would be 0 to 100. So when we plug in 0, we get out 32. When we plug in 100 into the function, we get out 212. So our range would be from 32 to 212. And I have skipped all these problems over here. Hopefully these make sense to you too. And if you have any questions about these, we'll go over those on Monday. But there's the answers, and if you need to press pause so that you can catch them all, please ask your substitute kindly to press pause. Thank you. All right, today we're also going to look at 3 ways to graph. Now, this is not new for most of you. I know you studied linear functions, linear equations a good bit last year. So we're going to work our way through a PowerPoint that does a good job of reminding us of the 3 ways to graph. So we're going to start from the beginning. All right, so we have used 3 different ways to graph already. You did that last year. Slope-intercept form, using your x and y intercepts, and point-slope form. Now, those of you that are new to Fayette County, this point-slope form may be new to you, so I'll slow down a little bit when I go over that. All right, how do we know which one to use? Here's your cheat sheet. Okay, if the equation is in standard form, so it's ax plus by equals c, it may be easiest to use your intercepts. If it's already in slope-intercept form, certainly use slope-intercept form. And if it's in point-slope form, then the way we do it is we plot the point and then apply the slope. So if it's in another form, you're going to rewrite it into one of these forms that you like the best. Okay, so which graphing method is easiest? Well, when you're given this equation, it is easiest to use slope-intercept because that's what it's in. So first we'd plot our y-intercept and then apply our slope from that point. Our slope is negative 1/3, our y-intercept is 2, so when we go to graph it, we'd plot the 2 and then count our slope, rise over run. Since it's negative 1/3, you can go down and right 3, or you can go up and left 3, either way. And then we can repeat again if you'd like more points. That is not your bell, that is the bell this morning while I'm recording. And then the line is graphed. The next method is showing us this equation. Well, it's in standard form, so which one are we going to pick? Intercepts. So we're going to find our x and y intercept. Now, the way we do that is to plug 0 in for one of the variables, then that finds the intercept for the other. So if we look at this, to find our x-intercept, we plug in 0 for y. And when we plug in 0 for y, we find that x is negative 6. So we'll plot the point at negative 6. To find your y-intercept, you plug in 0 for your x, and then we get that y is 4. So when we plot both of those intercepts, the x at negative 6, the y at positive 4, then we can just draw in the line. Our third way is when they are in point-slope form. So which graphing method is easiest? we're going to go with point slope. So we're going to plot the point, which is this x and this y. And so our point is negative 1, 4, and apply the slope. So plot the point, and from this point, apply the slope, up 2 over 1. Okay, so which method would we go with here? Hopefully you're thinking x and y intercepts. Which one is the graph of this? Y equals x plus 2. So which one has a y-intercept of plus 2 and a positive slope? Looks like it's number 4. We'll also talk about graphing linear inequalities, but we'll do that on Monday. Now, you have 2 things that you're going to do for today. What you're going to do is, first you have a little activity on graphing giving a situation, and you're only going to do the front side of that worksheet, and the front is actually labeled linear modeling. Then you have bookwork, and your bookwork is practicing graphing, and your bookwork is on page 250 of your textbook, and you are going to do problems 14, 17, 21 and 22, 30 through 32, 34 through 38, 40, 41, and 47. We'll check all those and talk about linear inequalities on Monday. Hope you guys have a great weekend.